Hi everyone, this is Saad Aslam, and in today's video, we are going to discuss the questions that are being asked in an interview regarding data structures and algorithms. So basically, data structures and algorithms are a very important part of any technical interview. So if you are going to be interviewed for any technical role at a software house or regarding any position like software developer, software engineer, and other technical roles as well, so data structures are going to play a very important part in that particular role. So mostly companies and focuses in depth regarding data structures and algorithms. So, if you are going to watch this video at the end, you will have a better understanding of the questions that are being asked in an interview question. And at the end of the video, I'm also going to share some resources that will help you to prepare in depth too. So, before moving on, make sure to subscribe my channel to receive notifications of upcoming videos. And also, I have started a playlist on competitive programming, so you will have a notification of those videos as well. So let's get started. And okay, so what is the data structure? So basically, data structure, the interviewer can start with a very basic question to boost your confidence and to start the conversation, and he will can ask you what is the data structure. So basically, a data structure is a way of organizing data so that data can be used efficiently. Okay, so there are different kinds of data structures available. We will move through all of the data structures in detail. So data structures are basically divided into two, like non-linear data structures and non-linear data structures. So in linear data structures, we have arrays, stacks, queues, and linked list. And on the other hand, for the non-linear data structures, we have trees and graphs. So, as we have discussed the data structures, now we are going to discuss the algorithms. So, algorithm is a process of finite, well-defined steps to be carried out to solve a particular class of problems or to get the desired output. So, mostly we have a confusion between the data structures and algorithms. So, the interviewer can ask you to what are the different data structures we have and what are the different algorithms we have. So, you need to make sure you know the difference between data structures and algorithms. So in algorithms, we have like sorting algorithms, insertion sort, bubble sort, quick sort, merge sort. And for searching, we have linear search, binary search. And for shortest path algorithms, we have. So you need to make sure you know the difference between these two. Okay. So let's first discuss what is a stack. So stack is a linear data structure which uses LIFO process, or FILO, you can say last in first out or first in last out. So basically, it's like a stack of books. Like you have one book, add the other added on the top, and if another added, it is in the top. So all the books are added in a vertical manner. So like when if element or if any book is to be removed, the book is removed from the top, then the other book after that. So basically, it make uses three operations, like it uses push, pop, and peek. So basically, push is to add the element in the stack, and the pop is to remove the element that is at the top of the stack, and peek is you just to get the element which is at the top of the stack. Okay, so in many cases, you must know the difference between pop and peek. So pop basically gets the element at the top of the stack and also removes it. But peak only gets the element at the top of the stack, not remove it. Okay, so you know the difference between two. So here in the figure, you can see the element is that is added at the top is removed first from the stack. So you must know how to implement a stack. Like the interviewer can ask you to implement a class of stack that will use these three methods for regarding push, pop, and peak. So you must know how to implement a stack. Okay, so there can be other problems like you have to implement a stack using queue, or you have to implement queue using stack. We will discuss queue in the later videos. or later slide, sorry. Also, I just as I have discussed, like I have started a playlist on competitive programming. So recently, I have solved a problem that uses stack. So the problem is a valid parenthesis problem. So you can check the playlist, and I have solved the problem completely in that video. So the problem description is like something like you have given a string and of parentheses, and you have to check that if the parentheses are valid, like if there's an opening bracket then there must be a closing bracket. So you can solve that problem using stack. I have solved that problem completely in that video. You can check that video after like watching this video. Okay, so the other data structure is queue. So queue, as the stack uses the LIFO, but queue using FIFO, like the element that is added in the queue first is removed first. Okay, so it's like a queue of person standing, and the element that is standing in the queue first will be removed from the queue first. Okay, so it has operations like in queue for adding in an element, dequeue for removing an element, and front and rear. So here you can see in the figure that we uh, you can the element at the back is in queue, and the element at the front is dequeue. So as we have discussed, like you must know how to implement a queue, how to implement a queue class, and all of these operations, and you how to implement a queue using stack. So they alternatively you have to implement queue stack using queue or queue using stack. So there are multiple problems on this. Linked list. A linked list like is the very, you can say, commonly asked person in technical interviews. In many scenarios, I have seen companies that the whole interview spent on discussing linked lists and the different versions of it. So there are different multiple problems on linked lists, and it is very important to make sure you have a better understanding of this concept. So in linked list, you have a head node, and each node is pointing to the next node. There's a pointer. Like you have a data and a next. So the each node is pointing to the next. Okay. So there are two parts like data and the reference of the next node, and there are multiple types of a linked list. Like there is a single linked list when each node is pointing to the next node, and there's a double linked list like there is the next pointer and a previous pointer pointing to the previous node, and a circular linked list. So let's discuss, you can say, one problem regarding linked list. So we have to find a middle of a linked list. Like you have given this, and you have to find the middle of the linked list. So during interviews, you need to make sure that you understand the approach. Okay, so you do not have to cramp the or learn the code thoroughly. You need to understand the approach. Okay, and during the interview, you need to think out loud. Like every step, you have to explain it to the interviewer what you are doing. It is not just like you have done all of the code by yourself and you are telling the interviewer like I have done the code, now you can check it. That's not like that. You have to make sure if you have written one single line, you have to explain it to the interviewer. So interviewer is something is like assuming that you do not know or you do not have a better understanding of what you are writing. So you have to explain each and every step. Like if you are initializing or you are initializing a map or any array, why you are doing this step. So you have to think out loud and to explain it to the interviewer. So like middle of a linked list, here the approach we are going to use is a two pointer technique. Like we are going to use two pointers, is a slow pointer and a fast pointer. Okay. So the fast pointer we will move 2 points next. Okay. So the fast pointer will move two nodes and the slow pointer will move one node. So when the fast pointer like traversing and the fast pointer will when moved to the null, like last node when it is pointing to the null. So at that particular point, slow pointer will be pointing at the middle of the linked list. Okay, you can see like at the first step they are both pointing to the same, and in the next step, the fast pointer move two nodes and the slow pointer move one node. And when the fast pointer reaches a null, then the slow pointer is at the middle of the linked list. So here's the approach of it. Like first, you have to explain it to the interviewer, like what approach you are going to use. Like it's not like I have asked you, like suppose I have asked you to implement middle of a linked list, and you just start typing code and do all of that stuff. But there can be a possibility you are uh, you have assumed the question wrong, and you are just taken 30 minutes to solve that problem, and the interviewer says that this is not the question I have asked you. So to avoid this, you first need to explain your approach, what you are going to use. Is if the approach is okay, and the interviewer says that you are good to go, then you can start coding. Okay. So yeah, we have discussed the approach. Now we are implementing it. So here you can see there's a method of print middle, and you are given a head of a node, and the slow pointer and the fast pointer are both pointing towards the head. That initially they are both pointing towards the head, and while the fast pointer um, is not pointing to the null, then it will continue traverse. And when the fast pointer reaches the null, then at that particular point, slow pointer will be pointing at the middle of the linked list. So here you can, in this way, you can implement the middle of a linked list. Okay, so let's discuss different kind of problems that can be implemented using a linked list. So you can insert and delete at the end of a linked list, and you have to find the middle of a linked list, find if a linked list is circular or not, and merge two linked lists to make one linked list. Okay, and reverse a linked list. So in reversing a linked list, there can also be different versions of it. Like you can reverse the linked list in group. Like you have given a linked list of 9 elements. You need to reverse each group of three. Like first three elements reverse, then next three elements reverse, and next three elements reverse. Group reversing group. Or there can be a question like you have given a starting position and an ending position. You have to reverse only the chunk in between the starting and the ending, and the elements between before the start and after the end will remain as they were before the reverse. So they only the chunk in between the start and the end uh, will have to reverse. Okay. Okay, so like infix, postfix, and prefix notations, like infix notation, the operator are written in between their operands, and in postfix, the operator is written after their operands, and prefix, the operator is written before their operand. So there can be questions like you have to implement how to traverse, or how to make sure that your code is traversing to the postfix notation. And they can also, the question will be something confusing, like they can ask implement reverse polish notation. So you must know like reverse polish notation is also postfix notation. Okay, and they can also similarly ask like implement polish notation. So what is polish notation? It is a prefix notation. Okay, so they can be questions from this. Hash map, very interesting, and basically I have seen many questions that are being asked regarding hash map in a technical interview, or and particularly in coding interviews. So in hash map there is a key value pair, like each key is pointing or having one value. Like the data types can be different, like the key can be of integer, and string value can be of string, or both key and value can be of string or int. So it is used in many cases or many questions, like if you have to find occurrences of a given alphabet in a text. Okay, so you can use hash map for that. Like you can use hash map something like if you can first have to make a frequency table. How to implement a frequency table? Like if the element, the alphabet we have to search, if the alphabet is like the string, like the first find the character at like the character at the index of the string, and if the character is in the hash map, then we are going to get the particular element and increase its frequency by one. And if it is the very first element and it doesn't contain in the map, then we are just adding in the map and initializing it value by one. So there can be many problems like this using hash map. Similarly, I have implemented a, to some problem in my comparative programming playlist. You can go and check it out after this video. So I have solved a complete approach using hash map. So you can go and check out that video and do some problem using hash map. Okay, so what is the binary tree? So in binary tree, the one root has at most two children, and each element in a binary tree can only have two children. Okay, so there is a difference between a binary tree and a binary search tree. So in binary tree, there is no limitation like what is the element at the left must be smaller or the element at the right must be greater. There is no condition like that in a binary tree. But when we are discussing a binary search tree, there are some properties that you need to be aware of. So the left subtree of the node contains only nodes with the with keys lesser than the node's root key. Like at all the elements at the, like if we have a node, okay, and the elements at the left will be smaller, and the elements at the right will be greater than the root. Okay, and similarly the subtrees, all subtrees must be binary search tree. Like all left must follow the properties of binary search tree, and all the right must follow the properties of binary search tree, and there must be no duplicate nodes. So there's a difference between a binary tree and a binary search tree. Okay, so there can be questions like you have to find lowest common ancestor in a binary tree, and you have to find lowest common ancestor in a binary search tree. So both implementation are different for both of the two. Okay, so the interviewers can ask to implement a binary search tree. So it is very commonly asked, like interviewers ask you to binary search tree. Many interviews, if you are preparing for an internship or any interview, so you must know how to implement a binary search tree. So you can see if root is a base condition we have, and if the key is greater than if root key is less than the key, then we are going to recursively in the right we're going to search, and otherwise we are going to search in the left. Okay, so let's discuss breadth first. So if you are given a graph problem, so these are going to be very useful. So breadth first search basically it starts with the tree and explore all nodes that are at the particular level. And after finishing all the nodes at the particular level, then it goes to the next level. Like here you can see the figure, like A first checks B and C, like A first check B and C, and then B will check D and E, and C will check F and G and H. Like all the nodes at one level are first finished, then it moves to the other nodes. So this this is the you can say approach breadth first search is used. And depth first search, as in depth first search, the root node goes to the depth of each particular node. Like it doesn't finishes all the nodes in the level. First it covers the depth of node, then it goes to the next node and covers the depth of it. So the algorithm starts at the root node and explores as far as possible along each branch before backtracking. So there can be questions, we need to first make sure if you need a BFS for it or if you need a DFS for it. Okay, so there can be multiple questions on it, like you have to find the diameter of a binary tree, okay, or if you have to find maximum depth of a binary tree. So what can be used for maximum depth of a binary tree? Let's pause this video and let me know in comments. Okay, so DFS can be used for finding the maximum depth of a binary tree. So, and finding the kth smallest element, like you have to find the second smallest element, third smallest element in a binary search tree. So, and the other questions like this. So, like preparing graph interview is very important. Graph questions are very important for interview questions. So you need to make sure you better understand this concept. Okay, so in sorting algorithms, like they are different. Like you have implemented like insertion sort, bubble sort, merge sort. So you make sure you know how this sorting algorithm works and what are the algorithms they use and what are the time complexities of these uh, sorting algorithms and what are the trade-offs like for any particular scenario what sorting algorithm is going to be used. Okay, so selection sort, bubble sort, insertion sort, merge sort, quick sort. Okay. So, like, also you need to make sure that you know the complexities of all these algorithms and what are the trade-offs, like for particular scenario, what uh, uh, sorting algorithm you can use. Okay, so here in the table, all of the average, worst, and time complexities are mentioned. Also, I'm going to make a separate video on finding time complexities of your the algorithms or code you have written. So make sure to watch that video after this as well. Like I'm going to make a separate video on that time complexity because writing a code and finding that time complexity are both important if you have any coding interview scheduled or if you are preparing for any technical interview. Okay, so as there are multiple questions you can prepare from here, that's saadaslam.com articles on technical interview questions. You can have multiple questions on object-oriented programming, data structures, coding interviews, and other questions as well. Okay, or and also I'm going to prepare further videos on different aspects of technical interviews, like on object-oriented programming. As for coding interviews, I've already started a playlist on competitive programming, and also the basic no do's and don'ts you need to know before a coding interview. Okay, so that's it for this video. I hope you have a better understanding after watching all of these concepts. Make sure to subscribe this channel to receive notifications of my upcoming videos. And if you have any questions and queries, you can let me know in comments. You can ask me on LinkedIn. I'm very active there as well. So if you have any questions, let me know in comments and see you in the next video. Bye bye.